Hello students, good afternoon. Today lecture is about the rate of reaction. Is our rate of reactions. In this chapter, we have to study about what is the effect of the rate on the chemical reactions. So the content of the today lecture is about the understanding of the rate of reactions to prove how rate of reaction proceed before the reactions and after the reactions. Number 2, the factor affecting rate of reactions. And the second class is collision theory. So the first one is the proper definition of the rate of reactions. So rate of reaction is mean that any change in the concentration of the reactant or product per unit time. For example, I have an equation. Nitrogen is a gas plus hydrogen is a gas form. They convert into ammonia gas. These are the three phases of the matter, like solid, liquid, gas and matter. So nitrogen is a gas in gas form, hydrogen is in gas form, ammonia is in the gas form. So the rate of reaction is any change in the concentration of reactant or product per unit time. For example, concentration means number of moles per unit time. For example, this is the example of the making of the ammonia gas. For example, before the start of the reaction, when time is equal to 0, because the definition of the rate of reaction is the change in the concentration of reactant or product per unit time. So every reaction depends on the time. So rate of reaction when the time is 0, the number of molecules of nitrogen is 0. Same time, the number of molecules hydrogen is 0. And in the product, there is no any conversion of the molecule in the reactant and in the products. After some time, after reaction, the time is equal to, for example, 5 minutes. The number of molecule of the nitrogen is, for example, 2. The number of molecule of the hydrogen is 3. Total is 5 number of moles. Convert into total is 5. So it means before the start of the reaction, the number of mole is 0. As you see in the nitrogen is the number of molecule is a 2 and the number of molecule of hydrogen is a 3. And in the product side, the number of molecule is a product is 5 molecule. I will show you the graph. In the y-axis, they show the concentration like 0, 5, 10, 15 and 20. And with respect to s-axis is our time. For example, 1 minute, 2 minutes, 3, 4 and 5 and so on. So this one is for reactant, this one is the product. According to the chemical equation and the definition of the rate of reaction, when time is passed decrease down when before the reaction the time is 0. There is no any change in the reactant and the products. After some time, for example 1 minute or the 2 minutes, the reaction proceed. Gases, nitrogen gas and the hydrogen gas convert into ammonia molecule. According to the graph, this line shows the reactant molecule, nitrogen and hydrogen gas. And this one graph line shows that of the ammonia gas. In this line, the reactant, it means the time is 0, no any concentration. After some time, the concentration of the reactant molecule, this one is the reactant and this one is your product. So after some time, after reaction, for example 5 minutes, the concentration of the reactant is reduced, slow down, because the total molecule, number of molecule totally convert into product molecule. So that's why the basic principle of the rate of reaction is that the concentration of the reactant is decreased with graduality of the time. After some time, the concentration of the reactant slow down and the concentration of the product is higher than the reactant. So this is the basic principle of the rate of reaction, that any change in the reactant and the products with respect to the time is called rate of reaction. So the basic definition example is ammonia. So nitrogen gas, hydrogen gas convert into ammonia. Before the start of the reaction, the time is 0. According to this graph, this line shows the reactant and this line shows the products. Before the reaction, there is no any effect on the graph of the reaction in the chemical equations. After some time, after when you have to some time, 1 minute, 2 minutes or 3 minutes, the concentration of reactant is slow down. Another mean that the concentration of the molecule of the nitrogen and the hydrogen gas is lower. At the same time, the concentration of the product is increased. It means that concentration is inversely proportional to time. This is a mathematical equation. When you increase the concentration of the reactant, time will be slowed down. At the same time, as the inverse relation, when you decrease the concentration of the molecule, the time is increased. So this is the basic principle and the basic definition of the rate of reaction, and this is a graphical representation of the rate of reaction and the basic equation. So I will show you what is the chemical equation to calculate the rate of reaction and what is the unit of the rate of reaction. For example, I have a equation nitrogen gas plus hydrogen gas. They convert into ammonia gas. This is the chemical equation number 1. Now you have to calculate how to calculate the rate of reaction of the reactant and products. Reactant and product. So to calculate the rate of reaction, if I am talking about the reactant, so rate of reactant is equal to, we have two reactant, number 1, number 2. So to calculate the reactant, the concentration of hydrogen gas in the bracket form minus concentration of nitrogen divided by time. How much concentration of hydrogen minus the concentration of nitrogen divided by time? For example, the concentration of hydrogen I have 3 molecules minus concentration of nitrogen is 2 divided by in 2 minutes. Just example for you. 3 minus 3 divided by 2, 1 divided by 2, 0.5 rate of reaction. This answer is correct, but you don't know what is the unit of the rate of reaction. Because in the science, chemistry, physics, when you have to calculate the value, you must add the unit of the specific example. For example, rate of reaction is equal to concentration divided by time. This is concentration, another is a molarity over time. Now, for further divided by molarity is mole per dm cube. So mole is a number of molecule or moles. Volume is the, in the rate of reaction we use cylinder. Volume. So concentration, the another term is molarity. So the molarity is mole per dm cube. The proper unit of the rate of reaction is mole per dm cube divided by time must be in second. So mole per dm cube per second. This is a unit of rate of reaction. So it means 0.5 rate of reaction of the reactant molecule nitrogen and the hydrogen gas is 0.5 mole per dm cube per second. So you can easily calculate the rate of reaction of the reactants and the rate of reaction of the products. And the unit of the rate of reaction is mole. The unit of the molarity is mole per dm cube and time is second. So the proper unit of this one is mole per dm cube per second. Now there are two types of rate of reactions. A rate of reaction, there are two types. Number one is homogeneous mixture, and the other one is heterogeneous mixture. They are the two types of the rate of reactions. Then after that, homogeneous mixture is same phases like solid solid, liquid liquid, gas gas. And then heterogeneous is solid liquid, gas liquid, liquid solid. Thank you so much for the today lecture. Bye bye.